last lesson we looked at magnetic flux, and this time we're going to apply that and figure out what's going on. The big guiding principle we're going to have is called Faraday's law. Faraday's law says this. It says the change in magnetic flux over time is equal to the negative of the induced voltage, or induced potential, if you like. If you have some kind of a calculus background, you might recognize this change in flux over change in time becomes a derivative. So when we're doing this without calculus, we're assuming a linear change in flux. In this course, it always will be, so we will just roll with that. This minus sign, we have seen a minus sign in an equation like this before, and it was in Hooke's law, where we said for a spring, our force was equal to negative k times x. That minus sign just meant that it was a restoring force. It opposed the displacement. That's what this minus sign means too. So this opposes the change. This isn't particularly helpful with just looking at it as an equation, so let me show you what I mean by this. If I've got a loop of wire like this, and let's give this wire some kind of resistance, and maybe this wire has a magnetic field passing through it. Right now, there is some amount of flux in this wire, in this loop. That flux doesn't have a direction, but it does have a positive or negative. It's a scalar value. So what we generally do is say we are going to take some direction, maybe into the screen, as being the positive direction. When we do that, and we figure out our flux here, we are going to get a positive or a negative flux. It's not exactly directional, but I'm going to talk about it like it is because it's a little bit less convoluted to go. So right now, I have some amount of magnetic flux that has a sign that's consistent with pointing into the screen. Maybe I can say that. I'm going to have flux that goes into the screen, or produced by a magnetic field pointing into the screen. That's fine, this loop does not care at all. It's a loop. But what happens when that flux starts to change? If I start to increase the flux that's here, so this is the flux I have now. If I start to increase the flux that's here, so if I start to add to this, then my change in flux is also into the screen. I will have more as time goes on. This loop does not like that, so it will produce a magnetic field to oppose that change in flux. So this is going to produce a magnetic field if the change in flux points into the screen, then the induced magnetic field will point out of the screen. So this is going to add some amount of magnetic field coming out of the screen. Now that magnetic field, it won't fully counteract the change, but the direction will be correct for counteracting the change. So I have a change in flux that points in, or a change, I suppose, in field that's pointing in. So I'm going to get an induced field that points out. Now right-hand rule says in order to produce a field that points out of the screen in the middle of my loop, I'm going to take my loop, put my right hand up so that my fingers in the middle of that loop point toward me, grab onto the wire, and when I do, I will follow my thumb around and I will find an induced current in this direction. That's a lot. What's really going on is exactly the backwards process of this. Because my flux is changing, the backwards order process, because my flux is changing, I am producing a voltage. That voltage is going to move in one direction or another. The direction that that voltage moves, or the direction of that voltage, produces an induced current. That induced current produces an induced magnetic field, and that induced magnetic field will oppose the change in flux. So in the forward direction, we're producing a voltage. That voltage produces a current. That current produces a field, and that field opposes the change. But in the direction that we actually solve these problems, we do this completely backwards. We say, right now, right, if I've got this field like this, that picture gets really busy so fast, then right now I have a flux that points in. That flux is changing because I'm saying, because of whatever reason, we are adding field to this. Maybe there's a wire over here that's carrying a current this way, which would produce, that's right the first time, which would produce a magnetic field over here. Maybe the current in this wire is increasing, so the field over here is increasing, that kind of thing. So somehow or other, we are getting a field that is increasing. So we are getting a change in flux that is adding to what we already have. As soon as we know our change in flux, we can say that our induced field is going to be the opposite. So these two will always be opposites. And then once we have that direction of the induced field, then it's a matter of right-hand ruling our way to the current. And this is where we say we need a current that's going to produce that be induced. So we need a current that goes this way. The next video will run through some more examples, but for right now, this is the idea of Faraday's law.